Guys, welcome back to the MongoDB tutorial. We have a good amount of overview about the entire structure of MongoDB and its documents. So now it's time to jump into the section 2, which will deal with moreover MongoDB replication and different details about the replica set and how to play around with it. So in this first video, we would be talking about the introductory part of MongoDB replication, in which we'll try to understand what exactly MongoDB replication is, the advantages of the replication and the replica set that we have, what are heartbeat signals, and what exactly is oplog. Okay, so now consider this. So you have one MongoDB instance wherein all the read and write operations are happening on the same instance. Now there always will be a possibility, what if this instance crashes? So if something like this happens, your entire data is lost, one thing. Second thing, there is a downtime until you put up another database, restore all the data back and connect it with your application server. Your application server will always show the error as server not available. So this is something which is not desirable for any advanced facility or any advanced database like MongoDB. So in this case, MongoDB, what it does is, it treats this one instance as the primary instance. Then this primary instance can have a maximum of 50 secondary instances. Now the relation between the primary and its secondary instances is called as one replica set. Okay. Now the advantage of this replica set is that one, the primary always has an alternative that if it goes down, one of the secondaries will become the primary. Second, you always have backup. So the secondaries continuously keep on backing up the data with whatever is there in the primary. And in this way, you have high performance as well as high availability. Now, how does this exactly work? So it like the primary continuously keeps on sending heartbeat signals to their secondaries. The secondaries in turn send heartbeat signals to the primary. In this way, both the primary and secondaries are aware about each other's health and status. Now, in a case if the primary is not responding for a long time, or if the secondary is not responding to the heartbeat signal for a long time, whoever is not responding is considered to be dead. If it is a primary who is dead, then an election will be triggered, and whoever wins out of the secondaries based on certain criteria, whoever wins will become the new primary. Now, when a primary is there and it has secondaries, the workflow is in such a way that all write operations from the clients will always happen to the primary instance itself. Now, whenever a write operation happens, the primary will generate something called as an operation log or an op log. Now, based on the configurations of the secondaries will copy this op log and execute this. The op log is nothing but all operations logged wherein any change has happened to the dataset of the primary. After executing this op log, the secondaries as well get the exact content of what the primary has. This assures you that 1. If the primary is gone, you have someone who has the backup. 2. You don't have any downtime. Moreover, this can also be used for load balancing. Like you can dedicate one of your secondary servers for special reporting facilities. You can dedicate one of your servers for special security. You can have one of your secondary servers only for backup purposes. And in this way, you can make sure that not only the read-write operations, but within the read operations as well, a lot of things are synchronized and balanced. And this is why this is one of the most important features and stuff that MongoDB has brought up around. For the implementation part,